Okay, let's keep going. For this table, I checked the textbook, and this is this is room temperature. Temperature is room temperature, 25 degrees C. Okay, here is the another type of potential. Okay, we just learned the activation of potential. Another type is ohmic of potential, which means that the current flows, and uh, the there is an electrochemical cell has electrodes and electrolyte. Usually electrodes, the resistance is quite small. Okay, since usually we use metal electrodes, but in a solution, the electrolytes, although it is liquid, but it has a certain amount of resistance. Okay, R. So the current flows through the circuit, through the external circuit, and through the inside the electrolyte. But in the case, the ions are moving anyway. The electrolytes, also have usually sometimes very large, the resistance. So when current flows, there is a potential drop due to this equation I multiplied by R. This is simply Ohm's law. Okay, so by the determined by the Ohm's law, this ohmic drop is pure loss of current of potential. So although you apply certain amount of external voltage, if there is a ohmic drop here, and then actually you apply the smaller voltage between two electrodes. Okay, so this kind of potential is called ohmic overpotential. Okay, so in order to reduce ohmic overpotential, you have to reduce this resistance. Okay, by adding more ions into the solution. Okay, anyway, this is another type. This is all the time exists. Okay, ohmic over potential or ohmic over potential. All right, and also there is another type of the potential loss, which is due to the concentration polarization. Okay, so the uh, the former two effects are rather easy to understand, but this one, concentration polarization, you have to follow me very carefully. This concentration polarization, this one occurs when the ion concentration at the surface is different from the ion concentration in the bulk. Okay, to understand this concentration polarization, you have to understand that since we are using electrodes, okay, electrochemical reactions take place at the electrode surface. Okay, so surface concentration is very important than the bulk concentration. Okay, although you have enough the quite high bulk concentration of a certain ion, if the ion concentration at the electrode surface is quite low, and then current may be very small. All right, because electrochemical reactions take place at the surface of the electrode. Okay, so don't forget that. Okay, so since these concentrations are different, and then we that phenomenon is called polarization. Okay, actually, polarization in science means several different it has several different meanings, but here polarization means that concentrations are different. Yeah, they are different. Surface concentrations is different from bulk concentration. Yeah? That is called concentration polarization. Okay. For example, at platinum surface in our previous example, the cathode potential is given by this the Nernst equation, and before we didn't put this subscript s. S means the surface. Okay, we simply used this uh, copper ion concentration, but actually this copper ion concentration is the surface concentration. Yeah, as I mentioned several times, because the electrochemical reaction takes place at the surface. Okay, if reduction copper of copper ion occurs rapidly, yeah, rapidly, that means uh, the surface concentration of a copper ion is very small, becomes very small compared to the bulk concentration. Why? Yeah, yeah. Whenever the bulk copper ion reaches surface, and then it immediately surface concentration becomes zero. Okay, so this condition may apply. Okay, because copper ion cannot diffuse to electrode as fast as it is consumed. Okay, now you see electrode is immersed in solution containing copper ion, and then now you apply potential, and then copper ions are removed by diffusion to copper metal, and then surface concentration will be very small, but still bulk concentration is constant. And then by diffusion, because there is a concentration gradient, so bulk copper ions are moving towards the surface, but the diffusion process is not very fast. That's why the concentration polarization sets up. Okay, so what was the result of this concentration polarization? The result is that you have to to apply more negative voltage to the electrodes. Okay, that's the result. Okay, as copper ion at the surface decreases, cathode potential becomes more negative. Okay, here so far we mm, considered three effects that affect cell voltage. Okay, O potential, ohmic potential, and concentration polarization make electrolysis more difficult. Okay, so ideal case is that uh, there is no over potential. This is activation over potential and ohmic potential and concentration polarization. If those effects are zero, and then that's the ideal case. But in reality, all the time they exist. So we have to consider, yeah, how to minimize those, the potential drops. Okay, these drive potential more negative, requiring more voltage from power supply. Okay, this one. Up to this point, this is theoretical. Okay, apply the potential, but since there is a this IR drop, you have to take a minus, because you have to drive more negatively, and also potentials should be considered, and you also the take a subtraction by this amount, and also it is not easy to calculate the effect of concentration polarization. This effect must be considered in this equation. Okay, but in your textbook, the author doesn't put this effect. Yeah? This is not easy to uh, quantitation quantification, okay, of this effect. Anyway, this is also important. Okay, okay, here is an example. Yeah, electrolysis of iodide to triiodide. This is oxidation, okay, in 0.1 molar potassium iodide solution containing 3 times 10 to minus 5 molar triiodide at pH 10 with hydrogen gas pressure at 1 bar. Okay, what is the reaction? Chemical reaction. This one iodide is oxidized to triiodide uh, to give rise to this one, and then as a result, hydrogen gas and hydroxide ions are formed. Okay, and then we break into two half reactions. Okay, so cathode reaction is what? Water reduction, yeah, to give hydrogen gas and hydroxide ion here. And then from the table, from the appendix, you see the E0 value is minus 0.828 volt. Okay, and anode, this one. Although anode oxidation reaction takes place, but now let's write in reduction form and then write the Nernst equation, and then we can subtract that term. Yeah, that's the idea. Anyway, in the triiodide, I'm sorry, in the negative sign is missing here, and it accepts 2 electrons to become a 3 iodide ion, and the E0 value is 0.535 volt. Okay, and then to calculate the applied potential, so let's calculate yeah, by considering these two reactions and then applying the Nernst equation. For the cathode, we apply the Nernst equation. This is given by this one, yeah? And then with the the hydrogen pressure is 1 bar and hydroxide ion concentration is 10 to minus 10 to minus 4, right? Because pH is 10. And for the anode reaction, we write the Nernst equation, okay, and we write it this way, and we since potassium iodide concentration 0.1 here, and triiodide is here, okay, 3 point times 10 to the minus 5, and then we get 0.490 volt. Okay, and then you have to at least apply how much, this divide this minus this one, and then minus 1.081 volt. Yeah, this is the minimum voltage, yeah, for this reaction to take place. Okay, actually you have to add more negative potential than this one. Okay, and now the here this the question B is the actual case. Okay, and then surface concentration of triiodide is quite let me see, surface concentration here, since you drive this one, and then it'll be increased a little bit, and 3 times 10 to the minus 4, and cell the resistance is 2 ohm, quite small. Actually this is very small, and current is 63 milliampere, and cathode of potential is, we simply assume, we take this value 0.382 volts, and anode of potential is 0.025 volts. Okay, what voltage is needed to drive electrolysis? In this example, concentration polarization is not considered. Okay, but actually you have to consider the concentration polarization effect. Okay, anyway, with these conditions, let's calculate. Okay, so the anode potential, let me see, for the cathode potential, nothing will change. Okay, but only anode potential will change because it contains triiodide here. Okay, and using this one, triiodide concentration at the surface here, instead of bulk concentration, we recalculate using this one. Okay, and we get 0.520 volt. And then here IR drop, this is called IR drop, ohmic polarization effect, and current is given here, and R is given also here, and of potential effects, there are two of potentials at the cathode and at the anode. You have to subtract all these two values. Okay, and then we get this one, and this is IR part and all potentials, and then we get minus 1.644 volts. Theoretically we get this one, and then we have to apply more negative potential than this one. Okay, yeah, at least you have to apply minus 1.644 volt more or more. Okay, more negative potential than this one. Okay, and now the topic is controlled potential electrolysis with a 3 electrode cell. this one, this part is quite intriguing. Okay, quite intriguing, and you have to carefully follow me. Yeah, I will try to explain as best as I can before take this one, and then let me see why there is no strange. There must be two electrode system. Okay, yeah, yeah, we will consider this part, later. We just simply follow uh, the, uh, the textbook. Control the potential electrolysis, as name indicates that you control the applied voltage with a three electrode cell. This is important, the three electrode cell. So far, we only considered two electrode system. Okay, in potentiometry, we considered reference electrode and indicator electrode. Okay, and here we consider only cathode and anode. Sometimes we what the working electrode and counter electrode. Okay, whatever the name, whatever the names are, we only consider the two electrode. Okay, one then two. But actually, in electrochemical experiments, we use three electrodes. We need another electrode. Okay, another electrode, one, two, three, and then that is called the three electrochemical system. Okay, why? There is a very important reason for using a three electrode system, and with three electrode system, the potential state controls, right, this three electrochemical system. Okay, with two electrode system, you don't need such a sophisticated controller. Yeah, you simply use what mm, variable power supply. Okay, here in this case, yeah, in two electrode system you need this one, this power supply, yeah, variable power supply. By changing dial, and then you can control this voltage. But in the actual experiment, people, you know I would say 99 more percent, more than 99% in the lab in the world, yeah, they use this three electrode system, yeah, using a potential stat. Okay, why? Let me explain. Okay, now this is electrolysis cell or electrochemical cell, and then there are one, two, three electrodes. This one is a reference electrode, and this one is a auxiliary electrode, and this one is working electrode. Okay, and depending on the oxidation or reduction, this auxiliary electrode may be anode or may be cathode, and working electrode may be cathode or may be anode. Okay, don't be confused at that. Okay, and with two electrode system, you don't have this reference electrode. Yeah, current flows between cathode and anode. Okay, but when current flows, this anode composition or cathode composition changes, because current means the reaction, okay, reaction rate. Yeah? then may then may cause great difficulties in potential determination. Why? Yeah, with current flows, with current flow. Okay, it is there is no assurance that each electrode potential uh, is defined. Okay, so through the electrode system, the idea is what? Is to separate current flow path and voltage applied path. Okay, here with to the electrode system, here is a reference electrode, and then this anode, I'm sorry, this cathode working electrode potential is all is only determined with respect to this reference electrode. Okay, but current flows between this working electrode and auxiliary electrode. Okay, think about the two electrode system, okay, without this one, this reference electrode, yeah, and then potential is determined. For example, in that case, the cathode potential is determined with respect to anode, and current also flows through anode. Yeah, with current flows, the anode potential may change with time, and then this cathode potential may not be constant. Okay, that's the for the experiment for a short time may be okay, but that's not ideal. So people invented this three electrode system, okay, using this reference electrode. Yeah, and then this one is controlled by a instrument called a potential stat, okay. And then let me say again, the potential is this one, cathode, in this case working electrode. This is important. Yeah, working electrode is the electrode of your interest. Yeah, the you are interested in one electrochemical reaction, and then that reaction takes place at a certain electrode called working electrode. Okay, in this case cathode, right? Because reduction takes place anyway. This working electrode potential determined is determined with respect to reference electrode, but current flows between this working and auxiliary electrode. Auxiliary electrode is also called counter electrode. Okay, yeah. All right, and you find polarizable electrode, which is the easily changeable the potential with a small current. Okay, that is the characteristics of indicator electrode. Okay, I I gave a small lecture about that, polarizable electrode, non-polarizable electrode. Okay, polarizable electrode is used as indicator electrode or as working electrode here. Okay, that's the characteristics of working electrode. Okay, but non-polarizable electrode, the potential is constant regardless of current. Okay, potential does not vary um, much with a significant current. Reference electrode is non-polarizable electrode. Okay, how do we measure potential of an indicator electrode with respect to the reference of the reference electrode? Yeah, using this potential stat, it is possible. Okay, yeah. With a three electrode cell system, can solve this problem. Okay, this problem is that this uh, the voltage change problem. Okay, the potential state with potential state, you see, here there is there is no current between this working and reference electrodes. Yeah? No current flow. Current only flows between working and auxiliary, and voltage is determined. Working electrodes potential is determined with respect to the reference electrode. Okay. Okay, let's stop. Temporary stop here.